Okay, so again, I'm Tanya, and I'll be presenting syntactic argument prediction in L2 English and the role of vocabulary knowledge in eye tracking study. So why are we doing this research? Well, despite how much we think we're preparing native Spanish speakers when we teach them English as a second language, whether we put a stronger focus on grammar and/or vocabulary will affect how they process and predict sentence context and sentence structures. Some past studies we used as reference. In 1999, Altman and Kamade showed that predicting the syntactic arguments in a sentence can be based on the verbs and real-world context in which they occur. And in 2012, Borofsky, Ullman, and Fernald showed that vocab knowledge can help with incremental sentence interpretation in both adults and children. Past research was done on native English speakers, so we wonder, would English second learners be able to predict what's coming up in a sentence the same way? Studying these relationships might give us insight regarding second language acquisition, and therefore a collaboration between Penn State and the University of Puerto Rico was born. The question, how adult L2 learners of English in Puerto Rico will react to a verb trigger, and how vocab knowledge levels will affect the predictions and interpretations for a sentence. We examined two situations separately: syntactic argument prediction based on verbs and real-world context in a sentence, and incremental sentence interpretation based on vocab knowledge. So what did we do? Similar to the studies presented before, we utilized Zoom, YouTube, Google Sites, Audacity, Pratt, and Elan Annotator throughout the research. And for both situations, we used the materials from the Altman and Kamade study, as well as the Borofsky, Ullman, and Fernald study in combination with some of our own materials. For participants, they were adult Spanish-English bilinguals who were born and raised in Puerto Rico and around the ages of 18 to 24. Experiment 1. To test syntactic argument prediction, the first situation was a display using the picture to the right from the Altman and Kamade study, but adapting to include only 4 pictures because we didn't include the subject of the sentence, in this case, the boy. The display included the target and 3 distractors, and the participant listened to sentences while being shown the array of pictures. So in this example, a cake, a train, a car, and a ball. The sentences contained both cueing and non-cueing verbs. So a more general verb like move versus something more specific like eat. An example using the picture, when we hear the boy moves the cake, well, obviously all 4 items can be moved, but when we change it to the boy eats the cake, the only edible thing would be the cake. And so if participants can use the verb to predict an upcoming word, we expect them to look at the cake more when they hear eat compared to when they hear move. We predict that participants should be looking at the target more once the verb is spoken in the sentence. You see in hypothetical graph 1, the fixation objects are located on the x-axis and the fixation proportion mean on the y-axis. The orange bars represent trials that contained a verbal cue, and the blue bars represent trials without a verbal cue. This panel is specific to the verb region, so notice that the target fixation is significantly higher for trials with a verbal cue than without, which would indicate that participants are able to utilize properties of the verb to predict the upcoming word. This is what we expect to see for a native English-speaking adult. And the situation should be affected significantly based on the English vocab knowledge of the participant, because it's been shown that vocab knowledge influences lexical prediction. Moving on to the results. As you can see, the axes are the same as before, and the colors represent the 2 different trials as explained. We have 6 separate panels. The vertical panels are showing fixation for when the participant was hearing the agent, verb, and target respectively. And the horizontal panels are split into high vocab participants in the top row, like our prediction, and low vocab participants in the bottom row. So in our example, the boy moves/eats the cake. The agent is the boy, verb is moves/eats, and the target is the cake. In the middle verb panel, when given a verbal cue, for the high vocab group, there's a significant increase in the fixation proportion mean to the target, compared to no verbal cues, similar to what we saw earlier. As you can see, the low vocab group was unable to make this connection when they heard the verbal cue. At the same time, we were able to test a second condition, which looked at how noun and verb information interact with each other. The participant was shown a display with 4 pictures, similar to the figure to the right, except in diamond formation. At the same time, they listened to sentences spoken in English by a female native English speaker. So here's an example using the picture. The pirate hides the treasure. When the participant hears pirate, looks are towards treasure, the target picture, and ship, the agent-related competitor, since pirate is related to both treasure and ship. When they hear hides, glances increase towards bones, the verb-related competitor, since you can hide both treasure and bones, but it's a little bit harder to hide a ship. And finally, when you get to treasure, obviously that's the target, and so glances will be mostly focused on that. As you can see, the cat is the unrelated distractor, and therefore the participant won't focus on it as much. Our prediction was that participants should be focused on the target and agent-related word based on the subject, then looking at the target and verb-related word once the verb is spoken. In hypothetical graph 2, we have the fixation objects on the x-axis again, and the fixation proportion mean on the y-axis. We have 3 groupings showing fixation for when the participant was hearing the agent, verb, and target respectively. And you can see in the agent panel, there are increased looks to the target with an occasional glance to the agent-related word. Then, in the verb panel, the looks to the verb-related word increases. And finally, in the target panel, most looks are towards the target. This is what we expect to see for a native English-speaking adult as well. Participant vocab knowledge size may indicate strengths of relationships between words, so higher vocab knowledge will allow participants to utilize the relevant cues to make the connections. Moving on to the actual results, you can see that the axes are the same as before, and we have 6 separate panels. The vertical panels are like the groupings previously, and the horizontal panels are again split into high vocab participants in the top row and low vocab participants in the bottom row. You can see that in the agent panel for both groups, looks are fairly evenly split between the 4 items. But in the verb panels, you start seeing patterns and differences between the high vocab and low vocab groups. Notice the pattern mentioned previously for native English-speaking adults focusing on the verb-related word shows up for the high vocab group, whereas the low vocab group seemed to be stuck on the agent-related word and didn't make the connection to the verb-related word even after hearing the verb, as you can see in that verb/low vocab panel. This suggests that vocab knowledge allows listeners to make better use of important cues to upcoming information present in the verb. So now what? The results of the study will not only be beneficial for understanding how L2 English learners predict and interpret sentences, but more importantly, we'll gain some insights into the most effective way for L2 learners to attain learning amidst the wide range of vocabulary and grammatical rules that are applied to the English language. This is especially interesting due to the differences between the Spanish language and English. A little about my PIRE experience. Like previously mentioned, we were planning on going to Puerto Rico, but with the changes that happened in the past year, everything had to be adapted to a remote setting. And therefore we said goodbye to the iLink 1000 and hello to Zoom and Elan Annotator to help us manually code eye movements. But nevertheless, bonds were formed, research was done, and of course, virtual tours of Puerto Rico were taken. I would like to thank the National Science Foundation for giving me this opportunity, Dr. Julie Ducias for pushing me to do my best, Dr. Katrina Connell for being so patient and helpful, Miriam and Heather for helping with making the experience go so smoothly, the University of Puerto Rico and Dr. Rosa Gusardo for helping me recruit participants, and the undergrad and grad RAs who helped with coding the data. Here are my references to the studies I mentioned previously in case you were interested. Any questions?
Tanya, thank you very, very much. I should perhaps clarify for the audience that coding the data was incredibly laborious because the PIRE students basically had to look frame by frame and look at where the eyes were. And of course, before they did that, they had to achieve some sort of reliability. And so Katrina Connell, whom I also must thank, patiently worked with the students until there was, I think, 80% reliability before the undergraduate students could code the data on their own. But now they are able to, add another instrument to their toolbox. So are there any questions for any of the students who presented today? Or for Colleen or Tanya, actually Tanya, who was the last presenter. Oh, Matt has a question.
Yeah, so this is a question for Tanya and Colleen as well. What do you think it is about proficiency then that leads to the lack of findings of prediction? Colleen, when you were finishing up, I was thinking, well, you need to predict multiple scenarios in order to get the result there. And maybe that's what's difficult, just juggling multiple scenarios. But that didn't seem to fit with Tanya's data as well. Your data, I don't think, contradicted it, but I'm not sure. Yeah, there's only one thing to predict, and they weren't doing it there in your experiment. So what do you think? What is it about proficiency?
I can go first. So for mine specifically, my vocab proficiency was cut off. There was a cutoff at the medium PPVT score, and although the high versus low differences were significant, we did have quite a small group of participants. So some of the differences and patterns that we were hoping to see may not have been as apparent or may not have shown up as much, since obviously with more participants, we would be able to see that more often. I think it's also definitely about like the exposure to the language. So obviously high versus low, that would indicate different kinds of exposure, but at the same time, most of the range for vocabulary proficiency for my participants were quite high. We didn't really have like a really wide range. It was like a somewhat narrow range, so it might have been also a little bit difficult to see any patterns that we were hoping to see. But hopefully with more participants in the future, we'll be able to see that more clearly.
I agree with everything that Tanya said, and just like same thing with my experiment. It was a relatively small group of participants who all had relatively high proficiency. And I think like a factor that could absolutely affect the prediction that the participants were experiencing is the like cognitive load of processing in the L2. And if they had a higher proficiency, maybe that's like a slightly less cognitive load, allowing greater rates of prediction. But I don't know if that's right. I'm just guessing.
Thank you.
Any other questions? There is, by the way, Colleen, there are studies that do show relation. There's a very recent study showing a relationship between working memory and ability to predict. There is also a study showing the number of images on the screen might actually also affect how what people are predicting. These are some really cool visual, the virtual reality studies showing that, yeah, that number of exemplars on the screen may matter, again, perhaps related to ability to process complex visual contexts, and that the complexity of a visual context does matter in the ability of people to predict, which makes us think that clearly working memory might play a role. So it's a good guess. All right, any other questions?